Um, I logged into Tetralit and to Dardel. I created a directory cluster intro, and then I fetched these exercises tarball in both places. I did not extract it. I will do that. So if you didn't already do this, then please do so, because we will have some exercises that you need the exercises tarball for in a little while. And you can see inside of the exercises directory that you get when you extract the tarball, there is a directory for each of the systems. At least most of the system. There's none for Bianca, but I guess you would use either Pelle or other and adjust. But inside those, there are some batch scripts and some small programs to run with the batch scripts, just for testing. So since this is Tetralit, I'm going into Tetralit. And on this, I'm going into Dardel. Okay, so I will continue here. I'm going to do an introduction to Slurm. And Slurm is a batch system used at most of the HPC centers in Sweden and in many other places as well. And there is a documentation and guides at each of the centers. So you can go there and look at that if you want to. So what is Slurm? Well, Slurm is an open source job scheduler, and it provides three key functions. It keeps track of all the available system resources. So it allocates to users exclusive, non-exclusive, or non-exclusive access to the resources you are asking for some period of time. And Joachim has already shown that. It also enforces local system resource usage and job scheduling policies. Again, shown. Provides a framework for starting, executing, and monitoring the work. It manages a job queue and it distributes work across resources according to said policies. Those policies vary a bit across the centers. It's designed to handle thousands of nodes in a single cluster, and it can handle more than 120,000 jobs per hour. So it can handle quite a lot. And there are several ways to use the batch system. You can either give the commands on the command line, or you can submit a job script. It's usually the case that it's a good idea to make a job script. If you ask for the resources on the command line, you'll have to wait for the program to run or send it to the background with ampersand. But more importantly, if you use a job script, you have an easy record of the commands you used, so you can reuse or edit it for later use, and that is generally very useful. So you can see what it was you did several months ago and make changes to it. So in order to run a batch job, you need to create and submit a Slurm submit file, which also is called a batch submit file, a batch script, or a job script. There are many names, and you can see them called any of those, and I guess even others, if you Google it on the internet. But it's all the same. And there are also other ways to submit Slurm. You can also work interactively. And there are these portals and GFX launchers that many of the centers have. But right now we are going to focus on the text-based batch scripts, which are the ones that mostly are what is used. So there are many Slurm commands, and I have picked some that are the most commonly used and useful ones. If you go to the Slurm homepage, there is more information. So there is LSalloc that is asking for an interactive allocation. We'll cover that very briefly after this section. And interactive is just another way of asking for an interactive allocation. Which one that works, or if either of them works, depends on the center. sbatch, the one you use when you submit jobs to the batch system. So you say sbatch and then the batch script. In a moment, we'll come into that. squeue, viewing the state of the batch queue. scancel, you cancel a job. scontrol show is used for more info on jobs on nodes. And then sinfo is used for information about partitions and queues. So first, there's salloc and interactive. Those, as I mentioned, we will look at briefly after this section. sbatch. Sbatch is used to submit jobs to the batch system. And that's always done as sbatch and then the name of the batch script. And that is true for any batch script. And you can name the batch submit script whatever you want to. It's often a convention to use the suffix .sbatch or .sh, but it's not a requirement. It's merely a way of making it easy to find in your directory, I guess. You can use any or no suffix. You can call it as you want, as long as you have an easy way of finding it in your directory with perhaps hundreds of files. Yes, Open on Demand and GFX Launcher. Here it's possible to run an interactive job with those on already allocated resources. Those are good for graphical applications, visualization, and simple jobs, job submissions. It's also good for things like Jupyter and MATLAB. But other than that, you should probably use a batch job, especially a regular batch job, if it's something that can run without input. So they're also good for automation of scripts and for reproducibility. So it kind of depends on what it is you're going to do. So here is a small batch script. We are going to talk more about it very soon, but right now I'm just going to use it to test some Slurm commands. And because of that, I'm not going to talk about it yet. There's just one thing. This script here is called simple.sh, and you need to change the project ID to your own. So if I go into serial, probably, well, maybe it's maybe an intro Slurm, I think. Yes. So the one simple.sh, I'm opening with nano. I don't know if you know this editor, but it's the easiest editor to use if you don't know any of the editor on Linux. So it looks like this. You can see it's the same. Where it says project ID, put your project ID there. If you are in the course project, then your project ID is the following. But otherwise, it's a different one, and you should use the one that you have. So now I have made this change here, and that means I can submit this small script, and I can use it for testing. So how do you figure out what your project ID is? Well, you can check your project ID easily by typing proj info. That will then give you a list of your projects and their project ID, and also some other info like which members are in them and things like this. It seems it will take a little while to return, so now something happened. So I have different projects here, and you can check and see which ones you are in as well by typing project info. So I'm just going to clear this. Okay, let's try and submit this batch script. Sbatch, simple. And when I submitted it, you can see I got a number here, and this number is called a job ID. And when it has run, you will get a file that's called slurm minus this job ID dot out, unless you rename it. Squeue minus me. I just want to see if it's running. And it has by now run. As you can see, there is now such a file. Let's open it and look at it. The only thing that's in it is the name of the compute node that I was running on, which makes sense. I was in actual fact asking for the host name, so I got what I wanted. Okay. And this is very simple. So you should go in and either copy this small script here if you haven't unpacked the exercises, or go to the exercises and to whatever cluster you are on and into intro slurm, and there will be a file called simple.sh. You can edit it with nano. And you can either give it a file name or not. If you give it a file name, it opens it, if there is one. You can edit it directly. You exit it by holding Control down and pushing X. If something was changed in it, it will ask you if you want to save and if you want to rename it. There's nothing else to this editor, at least on the surface. So it's an easy editor to use. Okay, so if you have some jobs running and you want to see what the status are of them, and if they are close to being finished or to running, then you can use squeue. Squeue minus you and your username, or squeue minus minus me gives you the same. It will give only your jobs. So that is useful, because otherwise, as you can see here, there may be quite many. This is everyone that's running, so you don't want that. So say squeue minus minus me, then you only get your own. And you can, I guess, submit the same job a few times. And that was fast. But now you can see here. The jobs are in the queue, they are pending. They are listed here. You can get the job ID from here if you didn't note it down. And it also tells me it runs in the main partition. There's only one really, that's tetralit. What is the name of the script? Or I can name the job my username, because I'm the one that's running it, and the status is pending. It hasn't run any time at all yet. Now it has finished. But what you otherwise will get here is that statuses can be completing or configuring or running or pending and things like this. There are also some other states. And it will tell how long it has been running. This one has ran for 3 seconds, for instance. It will say how many nodes, or rather how many cores, you have allocated. This one is using 2 cores. And it also tells you what is the name of the nodes you are running on. And in this case, I'm running on 2 cores, and this is on Kebnekaise in this example here. But here I didn't get any because it was not yet running. Okay. So here is a list of some of the states. And yeah, the main ones are probably completing, pending, and running. And you can find all of them on the Slurm workload manager page. And if you want to, you can try and do what I did. Simply submit simple.sh after adding in the correct project ID, and then do that several times until you can get to see the list of how it's going before it has already finished. You can see here, configuring. I'm hoping to catch one in running, but whatever. Okay, but try that out. So if you have some jobs running, or rather sitting in the queue waiting to run, and you suddenly discover you actually made an error in your script, or you made an error in your code, and you want to change that instead of letting it run and fail, because why waste time in the queue on that, or waste resources? So you go ahead and cancel, and you can do what you can do is you can cancel a specific job ID, or cancel -u and your username, or then you get all your jobs. Because maybe you had several versions of the same, and you simply need to make an addition to your code before you run it. And you can always get these with sq --me. You cannot cancel other people's jobs. Only the administrators can do that. scontrol show. You're using that for getting more info. So scontrol show, and then one of these job IDs here. I need to say scontrol show job ID. Then I get an output here that shows both what was the job ID, I knew that, the job name, what is the status now, who submitted it, what group they were in, when was it submitted, how long did it run, how long was it allowed to run, when did it actually start, because maybe it's set in the queue for a specific time. And you can also run this while it's running, or while you're waiting to see what it's estimating when it will start. You can see which course it ran on, which one was the host, if you are running on several. And other than that, memory, if there are GPUs or if it's CPUs, you can see the work directory and all these things. So that's very useful. And I briefly go over the options here, what it means here. So yes, you can also see what type of CPU you ran on, if there are several types and things like this. And yes, you can try that. If you submitted one of your jobs, one of your the simple.sh with sbatch, then you should have gotten a job ID, and you can try and look at this. It will be something you can access at least a short time after it completes. So scontrol show node, that is used to get information about a specific node, because maybe you want to see how many cores it has, how long it was up, if it's a GPU node, and so on. And what you could do is scontrol show node, and let's pick this one here, because that was the one we ran on. And then you get some information here. This is a node name, this is how many cores per socket, and things that which OS it's running and version. What is the state? Right now it's in mixed plan, so it's probably starting up to run something else. When was it last doing something? And all these things. And if it's a GPU node, also you will see that. Then we have the command sinfo, and you can use that for information about partitions and queues. So if I say sinfo, that's a little bit lot to see here, but it's mainly the tetralit is the main queue here, and it's listing which nodes are in state drain, draining, reserved, mixed, idle. If I did the same on Dardel down here, then I also get to see that a Dardel actually has several partitions that you can actually use, and Dardel actually requires you to give partitions when you are submitting. So you could have the shared partition, there's long, main, and so on, and there's a GPU partition. And you have to say which partition to run in. And in this case here, you can also see the nodes are idle or allocated, or if they are draining and things like this. And I think this is something you should test. So let's just take 1-2 minutes and try do the scontrol show job and scontrol show node and sinfo, and also to make sure that you have all tried to submit this very brief job simple.sh and seen that it ran. So I think let's try that, and let's take 3 minutes until 14:10 and do that. Okay. I hope people succeeded in getting this to run. So I will continue with the Slurm job scripts, because now we have seen some of the commands to how you can control our Slurm job scripts, but how do you actually write a job script? And this small job, if you look at the most simple one, it would be even smaller than the one we used. So I mean, this line here has to be there. This is the only reason there is one for Dardel extra is that it has to have a partition. But first you have to have this line here, the shebang, so that it knows to use bash to run it. And then we have the project ID. I believe there are some centers where it's not technically necessary if you only have one project ID, but it's easiest to just always put it there. Then you need to tell how long you want it to run. It's hours, minutes, seconds, and it can be at most 7 or 10 days depending on center. And then you ask for resources. If it's a simple script, you want just one core. This is actually tasks, but since tasks are, you have one core per task as default, this is asking for one core. And then I'm just doing something simple like returning the host name. So this is the very simplest batch script you could do. And one thing you pay attention to is here, if it's a directive to the batch system itself, it starts with hashtag sbatch, and sbatch must be capital letters. And you can comment things out as usual with a hashtag. And if it's for the, if you wanted to comment out a batch directive, you can put an extra hashtag in front of it. So yes, this was the project ID, the account you should use. So that is the one you find with project info. Capital N would be number of nodes, minus small n or dash small n, or in long form, minus minus n tasks equal is number of tasks. Cores per task is 1 as default, so this would then be the same number of cores. You cannot be sure it ends that all the cores are on the same node. In general, the system will try to do so, but you cannot be sure of it. If you have a threaded job or otherwise something that you absolutely need the cores to be on the same node, you should instead use -c or a combination of capital N and -c. -c or -c is cores per task. This changes how many cores each task can use. You can also use it to get more memory. For instance, you could ask for 2 cores per task, allocate 4 tasks and 2 for each. So that will be a total of 8 cores, but it's only using 4 of them. The rest of them only provides memory. We will talk more about this later. And then there is -t or long form minus time equals. You will find that most have both a long and a short form of these options. The long form makes it easier to remember, the short form easier to write, I guess. Wall time, how long it can run. Hours, minutes, seconds, as I said. I believe it is at least a week at all centers, some have more. -p is a partition. Dardel requires the use of it. Some of the other centers use it for requesting GPUs. In addition, there is splitting the output file. Instead of just getting slurm minus the job id.out, you can split it in one for errors and one for output. If you add %da to the file name, then that gets replaced with the job ID when you run it. And that's useful because then your name will not be overwritten each time you run the job. So this example here shows how you could, for instance, split in output and error and get them named process job id.out and process job id.error. So let's again look at the example script simples job. That was this one here. So first we had this line, the shebang. It's written in bash shell language, and that's what we're running it in. It's the only one that's completely compatible with the batch system, so just use that. Second, third, and fourth line are what would be called a resource statement to the Slurm batch scheduler. They are also called batch Slurm directives. And that's this line, and this line. I have also added a comment line in between them. So here you put the project ID, as I said. Then you have a wall time, and I mixed those around after writing. Project ID, how long, and how many cores or resources. If it's a parallel job, you ask for more tasks. And then you run the job. If you had modules you needed, you would load those in between here. You could do other things as well. And then you would run your job. So let's continue. As Joachim also talked about, the job will terminate when the time runs out, whether finished or not. So make sure you don't ask for too short time. But if you ask for shorter, for not too long, then it will not sit in a queue for as long as it would otherwise, because it will sit in the queue and wait for a slot that's big enough that it can run. But Joachim has already covered this amply. You are only charged for consumed time, so if you ask for more, it doesn't matter. And charged means to your project. So if you have, say, 5,000 core hours a month, you will use them up in the sense that when you have run more than those 5,000 core hours, then you will get lower priority. Your jobs can still run, it just takes longer before they start. So, yeah, ask for longer time so you don't risk the job getting terminated before it's ready, but don't ask for hugely much too much. So, as Joachim said, overbook a bit. There are a lot more commands and resource statement that you can put into the batch script. And we will look at some of them in the next section when we go into types of jobs, like parallel jobs and things like this. But right now, I will only mention a little bit about dependencies. Because sometimes you have a workflow that you have jobs that depend on previous jobs. You have what is called a pipeline, and that can be handled through Slurm. And what you would do is you submit your first job, and then usually you would wait for the job to finish before starting your next job, and you can do that by telling batch to the batch system to check that your previous job actually finished and gave OK. And then it starts the next job. there are several commands for this. So you can say it will always start after some specific jobs have started, or after they have terminated, after they have failed, after they have finished with correct with code 0, which means it ran correctly, or also when it has run all other jobs that have the same name and user. And I have an example for that. Let's see if I can find it in this section dependency. Here there is a script that is generating a matrix, and then I'm doing matrix multiplication. So those two have to run after each other. So you cannot multiply matrices before you have created them. So you would create it with this one, and you would then run it with that one, as said here. And you still need to change the project ID to be the correct one. And then you can start matrix gen. And then you have the job ID. And then you can use this command here to tell it to start the next one when it has finished. It's also, of course, possible to do this automatically, because maybe you would like to just push it aside and don't sit and wait for the first job to actually get to a point where you have a job ID. And you can do that with depend here, the small script here. This script will take the first job, and then the next job will depend on the first job. And you don't need to know the job ID at that point. And you can test this as well. And that is also here. So just one more thing. There are a bit about monitoring jobs. There is actually a section on this, but we don't have time to talk too much about that. But the main ones are squeue, and at LUNARC and C3SE, it's called job info. There's scontrol show job, and you can also have squeue -me -start. Then you also will get an estimated start time. Then there's job usage, and there is also some others, and they are in this section job monitoring and efficiency. Let's see, what time is it? Because I really want you to at least try to do this dependency one. So let's take 5 minutes.